Welcome, everyone, and thank you for joining us today. Today's roundtable topic is tips and trick around sanding operations. So we've invited Gary Beesonen with Timesavers and Dan Big with 3M. We've got a great presentation. If during the presentation you've got questions that come up, you know what you're seeing, there is a Q&A section on the right of your screen. You can enter questions there and we'll go through those at the end of the session, and then we'll also be breaking into roundtables, and Gary and Dan will be available in the roundtables if you want to sit down with them and have a chat. So Gary, do you want to say anything before I start the video?
Just want to say welcome everybody, and I hope it's very informative, and if any questions, feel free to ask us.
All right, we're going to start the video and go from there.
So anyway, I guess the first slide basically just talked about hints and tips for sanding operations, reducing cost, and improving the quality control. So the first topic the first thing is the introduction to Timesavers, basically who Timesavers is. We started in 1946, and we are now currently this year 75 years in business. So this just kind of shows an example of the timeline. And next slide kind of shows who's Timesavers today. You know, Timesavers US has 68 employees, Du Bois has 37. Timesavers BV, which is our international division, which is the Netherlands, they've got 85 employees. Plus we have 3 facilities over in our Taiwan facility that have probably around 40 people overall. Here's some more information on Timesavers, 75 years. The turnover of more than 60 million in US dollars worldwide. Headquarters is in Minneapolis, Minnesota. And then our international division is in Hoos, which is in the Netherlands. And so we're a worldwide dealer network, and we're one of the market leaders for woodworking and metalworking. And then it shows our locations: Minneapolis, Hoos, Netherlands. There's another location in Groningen, the Netherlands. And then we have Taichung, Taiwan. And then we have a showroom office in Shanghai, China. So the most important thing that I like to start out with when I talk to customers is the abrasive belts. So this first slide shows kind of like the abrasive grit scratch pattern. And basically we talk about peaks and valleys, because the mineral of the abrasive belt has peaks on the abrasive itself with the minerals that are being put on, if it's silicon carbide or if it's aluminum oxide, or could be a ceramic, or it could be a mix. So on the far left, it talks about a consistent scratch pattern, if you see up on the left-hand corner. And then the closer left is kind of the inconsistent scratch pattern, which shows on the red colored abrasive. And on the right shows the result of an inconsistent scratch pattern showing on a cabinet door. Any questions?
It looks good for me.
Okay. And then here's a typical sander, 4-head sander, basically where we start out with 120 grit on the first head. The second head's 150, the third head's 180, and the last head is a 220. So this machine's set up with 3 contact drums that are larger diameter, and then the last head is a drum and a platen. So on this screen, it basically talks about the different grits, and it's showing the peaks and the valleys with each of these grits. So for example, 120 grit, the 120 grit abrasive belt produces a scratch pattern approximately 8 to 10,000 steep in the wood fibers. Then you have to make sure that you do the next grit. You can skip a grit. We prefer not to skip any grits. So the next grit would be a 150, and the 150 grit produces a scratch pattern about 6 to 8,000 steep in the wood fibers. Then your next grit after that would be 180. The 180 obviously now becomes a little bit less depth of scratch. Now it's 3 to 4,000 steep in the wood fibers. And then last but not least, for the 4-head machine, we have a 220 grit, and it approximately is 3 to 4,000 steep in the wood fibers. So basically what a true abrasive grit finish for a scratch pattern, we must remove and blend it together the peaks and the valleys created by the previous abrasive belts. The 120 grit abrasive belt creates a pattern approximately 110 thousandths deep into the wood workpiece. The final abrasive grit of 220 creates a scratch pattern of approximately 3 to 4 deep in the workpiece. We must remove approximately 67 thousandths of material after 120 grit abrasive belt, basically to remove the previous grit scratch. Once we remove that, then the sanding head number 2 running 150 grit, the abrasive belt would remove approximately 3. And then in the sanding head number 3, 180 grit would remove approximately 2. Running 220 grit abrasive belt would remove approximately 2,000. So the stock removal would remove the peaks and valleys of the 120 grit abrasive belt and produce a true 220 grit abrasive scratch pattern. If you don't have it set up quite properly from one grit to the next, then what you're going to do by the time you get to the finer grit at the end is you're going to show a previous grit scratch that might be coming from a previous head. It could be the third, it could even be the first head that shows up at the end. So this is the real key of making sure that you know your abrasives, know what belt you're going to cut with on the second belt for the second head, that we don't take too big of a jump so we can maintain the proper depth of scratch all the way through the sequence. And then I've got some a caution notice here. Basically, when setting the abrasive belts for the correct amount stock removal, you must make sure that you do not exceed the abrasive belt stock removal capabilities. So here on the right side, there's a few things that talk about streaking, heat buildup, excessive graphite wear, premature abrasive belt loading, and then number 5, poor finish. So an example of this configuration would be that the polishing plat and sanding head assembly has a maximum stock removal capability of 3 thousandths. To exceed the 3,000 stock removal capability of polishing plat and sanding head would lead to the following. So you got 120 showing how high the peak is, 220 is showing how low it's going to be with that grit belt. And then this kind of gives you an abrasive scratch pattern showing the peaks and valleys for the different type of grits for anywhere from 50 grits, 60, 80, 100, 120, 150. You want to add anything in there, Dan?
I was going to say the biggest thing I think for consideration with this is even though we might be able to, we're going to leave a depth of scratch of 18 thousandths with that 80 grit. And maybe that 80 grit is capable of removing 30 thousandths at a pass. I think one of the things our customers can do to extend their abrasive life is to understand that just because a belt is capable of taking off X amount, it doesn't necessarily have to. And they're probably far better off from an abrasive life standpoint to have too many heads or more heads rather than trying to save some money and get a 3-head machine when maybe they could use a 4.
Correct. And that's what we're seeing today as we're selling machines, trying not to skip any grits. We want to basically progress the one grit followed by the next grit that's commonly used and not skip too many grits because that's going to prolong your belt life. Plus it's going to set up on the sander knowing that, hey, I've got all the right grits and I'm taking off all the right steps. So my finish should be perfectly ready for the next step, which would be for finish, or it might be some other process after that.
Absolutely.
Next slide is abrasive grit sequence. Basically, it's kind of talking about the same thing. We just want to make sure we progress in the proper sequence. You go 80, 100, 120, 150, 180, 220. Those are the type of sequences that you want to do. Skip abrasive, Bertolini too said you might not have the best finish when you start to skip too many grits. And then obviously this slide here is talking about, the abrasive grit numbering system that's used. It's kind of a common number system throughout the industry. It's a P grade type system on the standard abrasive belts from 80 all the way up to 220, if not higher. So this is kind of giving you the recommendation that we do not want to skip the abrasive belts from one sanding head to the next. Some of the tips on here has been noted several locations of the customer are running consecutive abrasive grits. Many are utilizing abrasive grit sequence of 120 followed by 150, followed by 180, followed by 220. The abrasive grit scratch produces an excellent finish, but does not have the stock removal limitations, or does have the stock removal limitations. So then the summary is, to achieve a true abrasive grit scratch pattern, it's very important to follow the correct stock removal from one abrasive belt to the next. This process will not only create a true final abrasive grit scratch, but also provide the longest abrasive belt life possible. So when you skip too many grits, obviously something is going to be affected from life standpoint on that abrasive belt. Anything you want to add there, Dan?
Yeah, and I think it kind of goes back to my previous comment. Belts are capable of hogging off a pile of material, but the easier you can work them, the more consistent finish you're going to get, and the longer abrasive life you'll get.
That's correct. So here's kind of a common setup thing here for common abrasive belts and what the depth of scratch is. And so when we start at the top, we got the stock removal and the depth of scratch together. So your abrasive belts depth of scratch for, let's just pick a 120 grit belt. It's an 8 thousandths to 10 thousandths deep into the wood fibers. If we went from 120 to 180, obviously the 180 depth of scratch is going to be 4 to 5. So depending on what you take off with the 180, if you take off at least 5, we always recommend anywhere from 4 to 6. Then you know that if you got the scratch 4 to 5 and you take off 4 to 6, you're basically 8 to 11 thousandths, which means you remove the 120 grit scratch. That's kind of how we look at setting up the right abrasive belt from first head, second head, third head, fourth. And then the bottom ones talk about the capability of the stock removal. So basically on, let's say, a 120 grit, the stock removal can take off 10 to 12 thousandths. The 100 grit's 15 to 20, it just kind of progresses there. So if you know that the 120 is 10 to 12 thousandths stock removal, the depth of scratch of a 120 is 8 to 10. So you know you have to remove that much more with the 180. So 180 is 4 to 5 stock removal. The depth of scratch is 4 to 5. You know you're at basically 8 to 10 thousandths. So we remove the previous scratch. Anything to add?
Yeah, I was going to say, I think the thing to consider here is if we think back to your peaks and valley reference, I think it's kind of important just to realize that you don't have to get all the way to the bottom of that valley on the next belt.
That's correct.
You can just kind of chip away at it and take a little bit off each, so that by the time you reach that 220 grit, the depth of scratch for your 220 is matching where your depth of scratch was for the 120, and just chew off a little bit at a time. You don't have to take it all off in one bite.
That's correct. And it's better to do it that way because then there's less heat buildup and so on.
Absolutely.
So then this is kind of a tips and hints regarding a method of checking the depth of stock removal per sanding head with a multi-sanding head machine. So basically it's just giving you kind of a step 1, 2, 3, 4, 5, 6, 7, and 8. You follow that procedure that way you can set the machine up to do the right proper stock removal per each grit per head. Then you can compare the readings. What I always do with the customer, if they don't know where the machine's at, the number one thing is to do a storyboard test. So instead of going in and checking each sanding head with a dial indicator, we'd run a board that maybe it's 4 or 5 inches wide, the length of the machine, and make sure we sand that board both sides so that we know that it's been sanded on that machine and it's sanded properly. Then we can take the boards and take off, let's say 30, 40 thousandths with a multiple head machine and stop the wood in the machine. And now you're going to basically, under pressure with the sanding heads and how much material you're taking off, you're going to be able to produce a story image of what that machine's actually doing. So you can mic your board and say, my first head took X. At the same time, you can check for alignment of the machine left and right when you have a board on the left side and one on the right side. And then you can check the second head, third head, and fourth head. This will give you the exact absolute reading of under pressure where that machine is sanding. Then if you know that the second head's not taking enough off, you know what you have to make an adjustment on. So that's kind of like a hints and tips to set the machine up to really find out where it's at. The storyboard is the first thing you should do to find out where the machine is set at.
Yeah, and the one thing I would add here, Gary, that's honestly one of my first go-to when we're looking at a machine setup is to make sure we're removing the correct amounts for the abrasives that we want to use. And I would say the one best practice I've seen is actually to use 3 boards. Make sure they're all sanded to the same thickness. Run one down the middle, one on the left side, one on the right side. And as Gary mentioned, you can check for head level. But the added bonus of running the one down the middle is just to see if you've got any hourglassing going on with your heads, especially if you're using rubber drums. You can see if there's if that center one is a little bit higher than your outside edges, because more often than not, customers are more likely to run them right down the middle rather than to use those outside edges like we would prefer they use the full belt.
Right, and that gives them the idea, like you were saying there, you can now tell, hey, has the drum got a crown in it, convex, something's wearing, conveyor belt's wearing, the bed plate's wearing. All those are the factors that happen when you run a part down the middle all day long.
Yep.
Over time, it's going to show. And this is called, basically the quick check sanding accuracy and tolerance and reading the white belt sander. So if you follow the guideline of how to do all this properly, like we're explaining, you'll know exactly what that machine's doing, and then you know the cautions, and basically the tips of what to actually do to correct the situation that you're reading from. And once we determine that the abrasive belts and everything's set properly, now we just want to make sure, okay, what kind of finish are we getting? Another thing that's very commonly seen out there in the industry is the finish defective chatter. So the common thing of chatter is, could be coming from a drum, could be coming from a number of things. So I've got a number of slides here that show you different things, what could actually cause chatter. I mean, it's not just one given thing. There's a lot of variables here that you could be looking at. There's some that point out right away that it could be in the abrasive belt, or it could be simply some kind of wear on the machine itself. So the definition here is the chatter is seen on a workpiece where there's lines and marks running across the width of the product. And so these lines run from left to right when viewing the product as a direction to run through the sander. When the product is stained, marked with a crayon type marker, the lines will have appearance like that, a ripple mark. So it's like a ripple effect. So you see all these lines, what we call chatter. Again, the marks run across the surface of the workpiece rather than with the workpiece. The possible items that can cause a chatter are many. Below is a list of most common probable causes. And one is the contact roll. So we have causes and solutions here. So one, the cause would be a contact roll out of round. And usually when it gets out of round, it's either a abrasive belt, might not be perfectly true, that causes the drum to taper, or it might be just a wear factor, like Dan was saying, running parts down the middle all day. Then that'll cause the drum to start to wear, and then eventually it becomes out of round. When the solution of that is basically the contact roll out of round, it's recommended to remove the roll and have the face of the body roll properly dressed or ground. That's the best way of doing it. There are other tricks to do it in the machine, but you have to do some making sure that your machine is level. And then there's some other things you can do in the machine to run a stationary board or run a board through it with sandpaper on it to dress the drum, or simply, hire the service technician to come in and true it up with a dressing device. There's another cause, which is a contact roll out of balance. Contact rolls, as they start to wear, they can come out of balance, and then we get vibration. And that's what can cause the chatter mark on the product. And of course, the solution for that is to remove the contact drum or have it checked in the machine with the balancing device to see if it's out of balance. Some of the other causes of chatter, it could be bad bearings. So it could be bad bearings on the contact drum. It could be bad bearings on the idler roll. It could be a number of things in the machine that has a little bit of movement, even though you don't think it's much. It might be enough just to cause that chatter. And most of the time, if it's chatter that's continuously always the same, and when you measure the mark's distance from one chatter to the next, it never changes. Typically, it's going to be coming from a mechanical portion of the machine. It could be a drum, it could be a motor, it could be bearings. So that's where you have to kind of narrow it down. Is it something that's random, or is it always consistent? If it's something that changes, it could be not the machine, it could be in the abrasive belt itself, or it could be another factor that's causing it. You have anything to add there, Dan?
I'm just impressed, Gary, because I just assumed that all chatter was caused by abrasive belts.
Okay. It's not necessarily true. I mean, the simplest thing on abrasive belt, the splice is perfect. You should not have chatter. If you still got it, I mean, a drum causes chatter. So it's tough to say you can never get 100% drum-free chatter. It's there, it's just you don't see it most of the time.
Correct.
And then there's other things such as, I know there's a lot of stuff on these slides for the chatter, so to read every individual thing would take a lot more time here. But, V-belts could be not a match set, could be loose, could be missing belts. So there's a number of things that can cause the chatter to happen. So these are some of the causes, like, even drum or the hardness being too hard for the abrasive belt that you're trying to use. Or it could be just rubber is wearing, or it's starting to come apart. Things like that will cause chatter. So this gives us a number of solutions to remedy the problem. And then motors can always come down to a motor being out of balance, or the motor bearings. So there's many different factors you have to rule out to determine what is the right one that's causing the problem, so you know how to rectify it. Machine vibration. If the machine is not level on the floor and it's moving around and vibrating, that can cause chatter. Sometimes you don't know that it's that, but simple as making sure the machine sits level on the floor and stable, you will be able to have a chatter-free finish. If the machine's bouncing around, that'll affect chatter. There's also random chatter. Random chatter where the mark appears in various areas of the workpiece and they're not consistent. So it's basically insufficient or inadequate sanding pressure what causes it. So you could have the head simply not level, and in a certain spot it's just not hitting properly, so it doesn't have enough pressure on it to give you the proper sanding. Or it just could be a tapered drum. It could be something worn that could be causing that random chatter as well. Those are a little harder to find because you have to search for what's causing it. Insufficient hold down pressure. Oops, I hit the button here. Insufficient hold down pressure. If the pressure rolls that hold the product workpiece in the machine to feed it, if they're not set properly, sometimes they can cause hesitation marks, which could be a random type chatter mark. May not be the abrasive belt, may not be a drum, but it might be something mechanically that it's hesitating. If the part hesitates for milliseconds, it could cause a mark. And it goes down to, just like we said on the previous slides, just loose fits, something moving around, feed drive hesitation. There's a number of things that can be ruled out pretty quickly when you start looking at the mechanics of the machine. Some of the simple things I've seen just by the mechanics of the machine where chatter, some people just don't lock the head down. The head's got to be locked down so it does not bounce around on one side. Because I've seen that a lot where I've walked in and the machine's running, they've been running all day, but all the heads aren't even locked and the heads are just sitting there bouncing up and down as it goes. It's not sanding properly, it's not dimensioning properly, but then it leaves a really poor finish. And then we get to the abrasive belts. This is the one that Dan loves the most. It's the simplest things to check the belt splice. The belt splice needs to be pretty close to being accurate of what the main body of the belt is. Needs to measure the same at the splice. If the splice is, usually I found if it's over 1,000 thicker, sometimes you'll get chatter from that. Typically, it's mostly around that 3 to 4 thousandths that really shows up a lot.
Yeah, and I was just going to add, Gary, that as you mentioned it earlier, that when you're running on a drum, especially a steel drum or a hard drum, it's going to be nearly impossible to avoid chatter. Obviously, we hope that we can minimize it enough with a proper splice so that those subsequent heads, and especially that final head in your sequence, will be able to remove the chatter, as long as we don't create too deep a chatter on the very first head.
Correct. And then there's other causes and solutions. You know, belt could be put together incorrectly from the factory, where one side's tighter and one side's loose. We call that an abrasive belt floppy, which means it's flopping on one side, and it sometimes will make a loud noise. Sometimes it gets really loud. It sounds like a flat tire. You're wondering what's going on, and the belt's just slapping around on that side and making a lot of noise. So that can cause finish problems on the machine. And usually chatter is the most common thing that comes out from that. Then we've got chatter that can even happen with a platen. So it's not just the drums. The drums are probably the most culprit of chatter, but then also a platen can do the same thing, where there's eccentrics where the platen goes up and down. Just all the mechanics as far as wear could cause a loose fit and cause that pad not to stay flat during the sanding process. It could be a bed. The bed's moving around. A lot of machines have gibs in them to help keep the bed from moving front to back. It could be something just moving left to right that cause a little bit, or just play in the jacks and so on. So there's a number of things that could cause even chatter on platens. You have anything to add there, Dan?
No, this covers, your point is that the platens are typically where we hope that chatter is erased.
That's correct.
But it is certainly an opportunity or one of the places that can cause the chatter as well.
Right, and you know, and for years, 100 years ago, it was all drum sanders, and then the platen came in to help resolve the drum chatter. That's how a platen started. You know, they first out had drum sanders, and then companies said, "Oh, let's make a wide belt." When the wide belts first came on, the first thing that some of the companies did, they made a platen head to try to remove the chatter. They'd still have a drum head with a sandpaper wrapped around a drum sander in front. Then they put a platen with a wide belt behind it. And then eventually they realized, why don't we put it on both? So when you look back over 100 years, that's how a lot of things started out with drums. And then when the finishes wanted to get better, then they introduced the platen. And the platen was to solve all of the issues that would cause by the drum, but that's not 100% true. You still can get issues with the platen. And these are just more tips and causes and solutions of other areas to look and why things are happening. You know, the conveyor bed assembly, there's looseness, movement, jack wears, there's all kinds of things that can cause these issues. Some of the other things that can cause problems with the dust collection. If the dust collection is so strong, it can pull the abrasive belt right into the hood. And sometimes what they'll do is start affecting the abrasive belt performance. And that can cause chatter, or it can cause just the pre-dulling of the belt to the point where the belt's not lasting very long. And I've seen this happen. I've seen it where people have missed it, and then come find out it's actually hitting the dust hood as it's under the sanding process. The dust collection will pull that belt just a little bit and just start touching the dust hood, and then that can cause some issues.
Yeah, and since most of those dust hoods are made out of metal, not wood, obviously that's something that's going to dull your abrasive pretty quickly.
That's right.
And sometimes it's not even the suction from the system, from your dust collection system. But if something gets bumped or tweaked, or that dust hood gets moved, keep an eye on that, because you don't, the abrasives hitting metal is going to cause sparks too. And from what I understand, you don't want that in your wood dust.
Oh, we don't want that in wood dust, no. All right, the next topic that we have here is abrasive belts, paper versus cloth backing. So the industry abrasive belts are generally provided with either cloth backing or paper backing. So cloth backing is basically typically 24, 36, 60, 80, 100. I've also seen it all the way up to finer grits than that. It's just a heavier duty belt construction. So cloth has its role in heavier stock removal. It has its role in operator error from not trying to damage a belt. From a paper belt, you have to be careful more than what you would with the cloth. But the cloth backing has its role in far as using it for heavy stock removal is the main thing, or at least having that to be the first head that gets all the abuse. What kind of thoughts you have on there on cloth versus paper, Dan?
Yeah, I would say for the customers that don't have the luxury of a 4-head machine and be able to complete that sequence in one pass, if you've got a single head or a double head machine and you literally have to pull the belts off and change the belts to run the product through to get your finer grits, those are the applications, other applications where I like to recommend cloth. And the cloth is going to be just more durable for the handling. It's easy to tear those edges or put some creases in those belts when you're taking them on and off. And obviously we like to sell you belts that are going to last longer than just a few minutes. So
Right.
Again, in addition to the durability, it's of the process itself, just the handling process. If you're changing belts and reusing them, then we'll often recommend cloth for the durability from the handling standpoint as well.
Next one's paper belts. So usually paper belts are generally, for lighter stock removal and for finish. So typically 120 all the way up to 240. We pretty much want to utilize paper belts. I prefer using paper belts anywhere from 150 and above. At least if it's a multiple head machine, the last belt is a paper belt because a paper belt does give you a better finish. It's a little bit less expensive than the cloth, so it saves you a little bit of money there. But it is a better finish using a paper belt versus cloth. About the same what you feel there, Dan?
Yeah, I think, and the biggest reason for that is the backing itself. The paper backing is much smoother than the cloth backing. For most of the cloth back belts, if you think of the texture, if you will, of your blue jeans, it's a woven cloth, and there's peaks and valleys within that weave. So you can put it on a flatter substrate like a paper, you're going to get a much more consistent mineral height, mineral depth, and that is really the core behind why you get your better finishes from paper versus cloth.
Then we've got a little thing about open coat versus closed coat abrasives. So the abrasive belts are available at either open or closed coat mineral patterns. Open coat abrasive has less abrasive mineral per square inch and is intended for a heavier stock removal. The mineral is generally sharp on the tips, whereas a closed coat abrasive has more abrasive mineral per square inch, is intended for lighter stock removal and final finish work. The mineral is generally dull on the tips. The closed coat abrasive belt is utilized when cross-grain scratch patterns are concerned, like cabinet doors and face frames. So it just brings the mineral closer together when it's a closed coat. And then open coat just means the mineral is wider apart.
Yeah, no, the open coat products tend to be best suited. If I'm going to set up an abrasive process, I'm probably going to put open coat 100, 120, 150 grades and then start to move to closed coat products when we get that 180, 220. Because as Gary's noted here, the open coat is a little bit more aggressive cut. The closed coat is going to give you a little better finish. So oftentimes that's the way I set that up. Unless of course you are sanding products that tend to load. And I won't even mention pine because pine loads everything. But
Right.
the open coat products are going to be a little bit more resistant to loading than what the closed coat products are, just simply because there's a little bigger gap between the mineral on the face of the abrasive.
And of course, we can always consult our abrasive supplier, 3M, for the proper mineral and backing. Thank you for your time. I know there was a lot of detail here. We could go on more, but if you have any questions, feel free to ask us and we'd be glad to help you out.
Thank you.
Thank you.
Okay, so we did receive an email from an attendee that some of these you chatted about in the presentation, but wanted to just kind of go over some of her questions. And I know a couple people from FITS are on here, so I'll throw them out to the group so everybody can hear. One of the questions was, how often should they clean belts? Dan, I think you're muted.
I'm mute, Dan.
Is it easier to hear me when I'm not on mute?
It is.
I mentioned to Gary ahead of time that I would try and tackle some of these abrasive questions here, and you know, belt cleaning. It's not easy to do. If a couple of different ways that belts can be cleaned. One is you can literally take a high pressure sprayer and wash belts. Obviously, you need to have a cloth belt for that. The paper belts don't hold up so well. So if you do want to clean your belts with a high pressure sprayer, you do need to be using cloth belts. And it's also important to make sure and hang those up and let them dry. So you would want to have 2 or 3 sets of belts just to give those products sufficient time to dry in between cleanings. Another way to do it, and I don't know if it's as popular, maybe some of you have heard of it, some of you haven't, but some dry ice blasting is an option. I don't know that any of the machine builders offer that. It's last I heard is more of an aftermarket add-on to your machine. I've seen that be effective. With the price of the dry ice and just that system to set up, you probably would need to be in a situation where your belts are getting loaded quickly and often in order for that to be of value for you. Otherwise, I think the key is to try, well, first of all, I mentioned it in the video, but try and avoid pine whenever possible. I do have a couple of customers that if they get a pine job, they just add X amount to the cost because they know that they are going to burn through more belts on pine than your standard hardwoods. Otherwise, I would say the other thing you could do to help provide or prevent loading, make sure you've got proper machine set up. If you start biting off a little bit more than the belt's designed to take off, you're going to load it more quickly. You're going to generate more heat, which activates those resins within the wood, those saps. And also make sure that your wood has reached low enough humidity. You want to make sure that the moisture content in your wood is low. If you start trying to tackle stuff that's got 15-20% moisture, you're going to load up a little quickly there too. So I'm hoping that answers the question.
Yeah, great. And like I said, we'll end this session in just a minute or two, and Dan and Gary will be in the lounge area if you want to sit and have a deeper chat with them. You kind of covered already the backing, cloth versus paper. You gave some information on that. what's the life expectancy of a belt that has been properly cleaned and cared for?
Yeah, that's honestly one of my favorite questions, and I usually answer that with this question: how long does it take to catch a fish? There's really too many variables, I think, to address that. Probably the best thing to do is, again, I like to use the example of a stock removal. If we look at just a standard stock removal, and I'm cheating, I'm looking at one of my setup cards, but if we're running 25 feet per minute with a 120 grip belt, we would typically expect to be able to remove 15 thousandths of an inch with that belt. If you've got a robust enough system where you don't have to reach, say for instance, if you can only take off 8 or 10 thousandths with that 120 grip belt, still reach your stock dimension goals, you're very simply going to extend the life of your abrasives by taking off less than the maximum. So your setup has a lot to do with it. I already mentioned a little bit of the humidity and the types of woods. We get into some panels. If we've got folks that are running 24-inch, 36 or 48-inch wide panels, and they run a bunch of 24-inch wide panels through on one side of the machine, and then they try and run 48s. Most of those folks end up having to pull those belts off between different panel sizes, just because one side of that belt has broke in or worn in more so than the other side, so they'll get a different finish from one side to the other. So that things like that can shorten the life of the belt. Like I said, I without trying to sound evasive, it really is a difficult answer. Some people, I've been in accounts that get a week and a half out of an abrasive belt, and I've been in accounts that will change belts 4 times during a shift. So it has a lot to do with square footage, really. How much are you running through it? How is it steady? If you're running 900 to 1,000 cabinet doors an hour, you're not going to see a week out of those belts.
Sure. That makes sense. Okay, well, I'm going to end the session. Gary, why don't you sit at table 1, and Dan, you can sit at table 2, and anybody on here join those tables, and like I said, you can have a conversation about and get into a little bit deeper if you have a specific need for your business. But thank you everybody for joining. And Gary, will you share those slides with me so I can share them with people that registered? Because there's some of those charts they may want to refer back to.
Okay, we can do that.
Yeah, that'd be great. Okay, great. All right, we'll go to the lounge now. Thank you.
Thank you.